We're going to look at the area of circles and regular polygons. So our formula for area is pi r squared, or pi times the radius squared. All right, so we're going to look at the circle here. Now I have highlighted the outside, so the circumference of the circle in blue, because what I'm going to do here is I'm going to partition this circle up. So I'm going to go ahead and cut it up into what are called sectors. All right, so we know.
All right, so I took and cut up our circle, and I cut them into what are called sectors.
So those kind of look like pieces of pies, okay? So it's the area between two radii and the intercepted arc. So I have 16 sectors here. What I'm going to do is I'm going to rearrange these. I'm going to rearrange them so that they're alternating directions here. Okay, so I'm going to get all 16 going in that direction, or going in those opposite directions. I'm sure you can do this much faster. I'm sorry, much neater, but I'm trying to do it quickly. Okay, now I'm hoping you're kind of seeing why I highlighted the outside so that you don't lose it. So I highlighted that circumference, remember. Let's see, we'll put it down here. Almost there. All right, so now I have all 16 pieces here. I have all 16 pieces, and we have made somewhat the shape of a rectangle. I'm sorry, a parallelogram. Okay, now if I could cut these again, I'd have 32 and then 64. And really, the more I cut these, the less of an arc I actually have here, and the arc becomes very, very small. So think about, I have half of my circumference up here, half of my circumference down here. Okay, so knowing that, we know area of a parallelogram is base times height. So here's half of my circumference down here. The height goes like this, and that is a radius. Okay, so the height is a radius. So let's stop and think about that a second. All right, so we said area is equal to base times height for a parallelogram. Our base, we said, was half of our circumference. So that's 1/2 of 2 pi r. The height of this is going to be a radius. Okay, so let's simplify here. We know 1/2 times 2 is just a unit of 1, so we have pi r times another r, which is pi r squared. So the area of a circle can be found by pi r squared. So now that we know the area is equal to pi r squared, let's go ahead and do an example. So here my radius is 5, so I have pi times 5 squared, which is 25 pi square meters. And again, just like what we're doing with circumference and with arc length, we can leave our answers in terms of pi. To find the area of a regular polygon, we're going to use this formula here, 1/2 NAS. N stands for number of sides. The A stands for the apothem, and this is a new word for us, so apothem. The apothem goes from the center of the regular polygon, and it meets the edge at a 90-degree angle. Okay, so right here. Okay, and it comes from this isosceles triangle. So if I were to draw in all of these, are called radii, even though it's not for a circle, it goes to the vertex of the shape. Okay, if I draw those all in, I have an isosceles triangle. So it's really the height of that isosceles triangle. Then we have S, which is the side length. So let's take a look at an example. We know area is equal to 1/2 NAS, so 1/2. The number of sides, we just need to count those. We have 1, 2, 3, 4, 5, 6, 7, 8 sides. Our apothem length is given to us. That is the 14.49. And then my side length is given to us in blue there. That is 12. So really I just need to type this into my calculator. And I get 695.52 square units. We're going to do one more here. We're going to find the area of a regular hexagon. So again, we know area is 1/2 number of sides times the apothem times the side length. So let's figure out what we know here. The number of sides, because it's a hexagon, we know is 6. Not sure of the apothem yet. We're going to figure that out. And we know our side length is 16. So the reason I brought this hexagon out is because if you remember, a hexagon actually gets divided into equilateral triangles. Okay, and the reason I know that is around the center we have 360 degrees here. If I divide that equally among 6 angles, that tells me that I have 60 degrees here and all the way around, right? And again, if these have to be isosceles, then I know I have 3 60-degree angles, which means I have an equilateral triangle. Now, think about that equilateral triangle. Okay, if I draw one out specifically, here's 16, right? All sides are 16. If I draw in that height, keep in mind this was a 60-degree angle. This has to be 30. So here's our 30, 60, 90 triangles. If I know the hypotenuse here is 16, I know the short leg has to be 8. The long leg is going to be 8 radical 3. That is actually our apothem. Okay, our apothem here is going to be 8 radical 3. So now all I need to do is multiply this together. When you have a radical 3, a lot of times I just leave it in terms of radicals. So I just simplify it as much as I can. So let's see, 1/2 times 6 is 3. 3 times 8 is 24. And 24 times 16 gives me 384. So that's 384 radical 3 square units. And again, it's okay to leave the radical in your answer.